Hello everyone, welcome to MSK Academy. In this video, I am going to explain about mutual inductance. What is meant by mutual inductance? We are applying current to the one coil. It produces the magnetic flux lines. That magnetic flux lines is linked with the near the coil. This concept is mutual inductance. See the diagram. B1. The alternating voltage is connected with the coil 1. It is a closed circuit, so the current I1 is flowing through the coil 1. The coil 2 is a open circuit. In open circuit, the current value is equal to 0. In coil 1, due to the current I1, the total flux value Phi1 is produced in the coil 1. Phi1 it is equal to Phi11 plus Phi12. Phi11 means it is a flux only linking with the coil 1. Phi12 means it is a flux is linking both coil 1 and coil 2. We are applying alternating voltage to the coil 1. We find the EMF produced in the coil 2. According to the Faraday's law, due to that rate of change of flux, EMF value is produced in the coil. Here, we are applying alternating voltage. It consists of positive half cycle and a negative half cycle. The produced flux also positive half cycle and negative half cycle. Due to that variations in positive and negative half cycles, the EMF is produced in the coil 2. That EMF value is directly proportional to E2 is directly proportional to d phi 12 divided by dt. E2 it is equal to N2 into d phi 12 divided by dt. Generally, the flux value is directly proportional to current. The mutual flux Phi12 is depends on coil current 1. So, in the first equation, I replace the flux value by current. I write E2 is directly proportional to di1 divided by dt. E2 it is equal to M into di1 divided by dt. M means mutual inductance. It is a proportionality constant. The first equation and the second equation, it represents the EMF produced in the coil 2. I equate the first two equations. N2 into d phi 12 divided by dt is equal to M into di1 divided by dt. Denominator values are equal, so I cancel the dt terms. N2 into d phi 12 it is equal to M into di1. I calculate the mutual inductance value M into N2 into d phi 12 divided by di1. When we are applying alternating voltage to the coil 1, we find the EMF produced in the coil 2. That time the mutual inductance M it is equal to N2 into phi 12 divided by I1. In next case, we are connected the alternating voltage to the coil 2. We find the induced EMF produced in the coil 1. In coil 2 it is a closed circuit. Due to that current I2 is flowing through the coil 2. The flux value Phi12 is produced in the coil 2. Phi12 it is equal to Phi22 plus Phi21. Phi22 means it is a flux is only linking with the coil 2. Phi21 means it is a flux is linking with both coil 1 and coil 2. Already I explained the first case. We are applying alternating voltage source. It consists of positive half cycle and negative half cycles. So the produced flux also is the alternating flux. It consists of positive and negative half cycles. Due to that variations of positive and negative, the EMF is produced in the coil 1. That EMF value E1 is directly proportional to d phi 21 divided by dt. E1 it is equal to N into d phi 21 divided by dt. The mutual flux phi 21 is directly proportional to the coil current I2. I replace the flux by current I2. So the EMF produced coil 1 E1 is directly proportional to di2 divided by dt. Then next equation E1 it is equal to M into di2 divided by dt. Third and fourth equation represent the EMF produced in the coil 1. I equate the third equation and the fourth equation. N1 d phi 21 divided by dt it is equal to M into di2 divided by dt. Here the denominator values are equal. I cancel that values. N into d phi 21 it is equal to m into d I2. I find the mutual inductance value. M it is equal to N1 d phi 21 divided by d I2. I connected the alternating voltage to the coil 2. That time the mutual inductance value M it is equal to N1 phi 21 divided by I2. Thank you for watching my videos.